Bonjour, my name is Eri. I work at Google, where I lead the AI cybersecurity research effort for both Google and DeepMind. And today, I am really happy to share with you a little bit about how we think large models are going to reshape the cybersecurity landscape. And before getting started, I know a lot of you want the slide, so if you want to take a second to just take the URL and download the slides, then we'll be well on our way and we can enjoy having a conversation. Also, I did time the talk such that it is about 30-35 minutes, so we have time for questions because it's more like a conversation. No one knows the future. I would gladly tell you what I know. But as always, different perspectives are more than welcome, so please let's take a little bit of a moment at the end to have conversation and questions. The last thing I would like to mention, there's a lot of people outside, and for those who will have to watch the talk online, I deeply apologize. I wish we would have had a larger room. I did try to reach RSA to get a larger room. Sadly, that is the largest one. So for all of you who are online, my deepest apologies. Hopefully, eventually, we'll have larger room for popular session. And don't forget, as you also as well, which are live, to reach out after the talk and talk about this. I'm always excited to talk with everyone on what to do for AI with all of you. All right, with that out of the way, let's get started. So there's a lot of hype or reality around the AI being able to revolutionize the world. And the fundamental reason for that is large models, which came to be very, very popular in the last year and a half, have this incredible capability to understand multimodal requests. You can pass it image, text, or video in a natural language. And what it does is, for the first time in the last 2 years, people are able to talk to the AI. And that is a major function change because people who before was more like a specialized field where you'll have to correct your data, mangle your data, put it into a dense vector, and so forth. Now you just talk to the AI, and the AI somewhat do what you want, and you have conversation. And so we have opened the realm of AI through this very, very simple and natural interface to a whole lot of people. And it has completely exploded, and people are really excited. A word of terminology is, I'm going to use the word large model, or I will try at least, to denote those models which are what we call billion parameters. So a large model is something which have about 2 billion parameters, which is about parameter number of neurons that the model has, and they are trained on billion scale example. The first version of them were called LLM, large language model, and I apologize if I use one or the other. I'm still not used to the LM term, which now have images and text, but essentially those are those very capable large models. And what makes those models so powerful is their generative capability. So essentially, now you have these things where you can talk to it and say, hey, generate me an image, and boom, you get an image. Or, oh, I have a problem with my code, how do I debug it? And boom, you get some answer to your code. We even had this crazy person who posted on Twitter that was awesome, who had a problem with his code, didn't know what to do, so he took a video of him going through his code and talking to the model, and did upload it to Gemini, which is Google Model Line, and then he got, oh, that's where your bug is. And that is actually a truly awesome experience, which is way further ahead than we had before. And so that's, in a sense, to catch up everyone to what we're talking about today is those models. And our experience at Google has been with what we call Gemini, which is our large language model line, and people use them through the web interface or on the mobile phone or even through API to generate code, ask questions, generate images, and so forth. So that's one of those. That's what we've been using internally, just to give you context. Of course, there are other ones, ChatGPT, Claude, and so forth, which exist. And the question is, how those very large models are going to disrupt the balance of cybersecurity? And essentially, I think there is two sides of this equation. The first one is, on the offensive side, what it's going to do is lower the bar for the attacker. And what I mean by that is, you know a little bit about security, you want to hack a website, you might not be able to use the right tool, might not be able to understand code at the level you need. If the model is able to assist you and help you to that, you have essentially a gain of function for the attacker. On the flip side of that, and I think that's the part where I'm the most excited about, is the model are becoming more and more capable and will help Defender to scale our defense capability. And in a way, my hope for all of us as a community is it probably will end the asymmetry of security. What we want is the model to do so much heavy lifting for us as defenders that we will regain not only balance, but maybe even get the upper hand with those AI assisting tooling that we're going to build. And you're like, yeah, I know AI. It's going to be all over the show floor. Disclaimer, I'm a researcher, so I don't have anything to sell you. And you'll see a number of product and a bunch of talk. And you're like, yeah, is it a revolution? And you might be right to be skeptical. There was two AI winter before, right? We had the promises of AI in the 1970s, in the 1980s, and both times it was very hype and then flake out. So why not three as a charm? Why not a third winter? Well, I think this time is a little bit different. And what I would like to do today, and that's why I said it's a conversation, is talk about how concretely, from our experience, down the trench, we are seeing sliver of how the cybersecurity offensive and defensive capability are being reshaped today. So this talk is going to be a lot of work in progress, and what I'm asking you is to think about it as not what is today, but given what is today, what is going to be in 2 years. And I think hopefully that forms you a mental model of, okay, for very key capability, where we're going. I propose we start with AI offensive capability and how that is going. And so here's a beautiful picture of the Pope in a very beautiful garment. And it made the round in the internet, I believe, 2 years ago. And people will look at it and were like, is it real, is it fake? And of course, our internet slut decided that, well, you know, the glasses are not quite right. The cross is a little bit blurry and clearly not human hand, so clearly it's a fake. Totally true, it's a fake. And how about that one? Yeah, and so this is 2 years after, and that illustrates my point of gain of capability by the model. So this is much better, right? The glasses are quite on spot. We don't see the hand, but current model do a hand pretty well. The cross is a little bit off. It's not properly attached, so still a little bit way to go, but this is very, very fooling. And if you don't look very carefully, those type of images are fooling. And there is probably such a gain of quality that eventually distinguishing a real image from a fake image is going to be, by the naked eye, is completely impossible, right? And that has been weaponized. This is probably the most famous example of a deep fake. In one of those two videos, left and right, Zelensky, basically at the onset of the Ukrainian war, asked to surrender. So, dear audience, which one is the fake one? Please raise your hand if you think it's the right one. 1%, okay. If you think it's the left one, please raise your hand. All right. So you all have guessed mostly correctly that the left one looks a little bit more blurrier, and so that is correct. The left one is actually the fake one. We believe that was made by a nation state at the time. And yes, it's a little bit easy to tell somewhat, but try to imagine that on a Twitter feed or on any social media. That's way harder to say. And that was the beginning of at least the most brazen example of disinformation done by deepfake. Fast forward 2 years, so 2024, now we have those AI generative capability being commodized, and there is quite a bit of tool now who help the attacker to generate fake images, fake audio, and fake videos, right? There is this alleged scam where someone went on a video call and pretend to be part of the finance worker and trick to send $25 million. And so now we are into this place where the most transformative part of GenAI, at least for security, cybersecurity on the offensive side so far, has been this ability to impersonate people, which is going to give us a lot of complexity in how we secure and how we trust remote access and remote phone calls. So, for example, there was also this terrifying story of someone hearing the voice of their son on the phone and trying to really think that this was a scam of like a mug in London scam, but on the voice, and you can recognize the voice. So if you cannot trust the voice, you cannot trust the video, then now we are in this very different stage of impersonation, and that's probably the most concerning capability today. We're going to explore the other one now. So there is a lot of activity on the black market towards using large model for black market capabilities. For example, the best paper I've seen so far is the one which is linked on the slide, and they did a study of quite a bit of those, and you can see there is quite a long list of them. Some of them are pre-trained models, some of them are using jailbreak prompt, meaning they are using either company behind the scenes to try to actually bypass the safety systems. And the advertised capability are around malware, phishing, and scam side. So on the malware side, probably writing some of the script. Phishing email is personalize your phishing email. And scam site is generating a phishing site, essentially. Interestingly enough, they also looked at can you use the model to generate vulnerability, which is the thing that people are the most concerned about, is ability of the model to write exploit. If you look at it, this is the only example they have in the paper. Yes, the code compiled, that's correct, except it is not working, right? As so far, the shell code is not a working one, and they say, well, you have to plug yourself the access to the API, so really a bunch of A output into a buffer is not necessarily an offensive capability. There were other papers who came out in the recent months about the model being able to exploit. But so far, the exploitation capability seems to be fairly limited, which is also our experience at Google with when we do evaluation of the cybersecurity dangerous capability of Gemini. And OpenAI report as well would emphasize that we are not there yet at the moment. So that's where we are. The other thing to mention is what is nation state are doing. So yes, it appears that nation states are actually indeed using GenAI capability and have been abusing, I would say, many of the large language models which are available. So far, it seems that they've been used for translation, technological research, including satellites, and script refinement, putting a script and trying to mutate it and so forth. Disinformation capability and, well, reconnaissance, which is getting information about a specific person or specific organization. So nation state is doing it. Attacker will do it. It's going to be part of the playbook of everyone to actually use those. And if you put an AI system, it also means that you need to make very sure that your own system is not abused. So taking a step back and summarizing all those information, where do we think we are today? And today means as of May 2024. For the phishing, I think the risk is pretty high. We will see more customized phishing, which are going to use the model to customize them in a better way. That's mostly going to be for BEC, I assume, because this is where you want to impersonate the chain the most. For large-scale phishing, there is a problem of like A, model query are pretty expensive, and B, they tend to try to do poor English to try to lure the most gullible people. So there is some reason to not believe that they're going to be large-scale one, or at least not yet. Fake audio, video, and phishing and scam, that is also, like, as I said, the top concern. Now, malware, I would rate the risk as low so far because, as far as we can tell, the capability of the model to write novel code is none, and the ability to mutate code is somewhat okay, but sometimes it got it wrong, and we'll talk more about that. So this is more low risk. Misinformation, like phishing, is extremely high, probably the highest one we have. With elections going through the world at the moment, it's one of the top concerns. So I would put it as high as phishing and put those two as on top of my list. And then the one we need to talk about, because it's important, not yet a risk, but proliferation, which is, can someone ask a model how to build a bomb? Nuclear, radioactive, chemical. this is a real threat. You probably really don't want AI to give capability to attackers on that domain. All companies do alignment to avoid that. And so far, I will write this risk as the lowest. So important to keep an eye on, but not yet to lose sleep over that one. So hopefully that is about where I think we are. Happy to, after the talk a little bit about more specific use cases, but really, I think we are on the fake generation as the #1 threat we're going to face in the next upcoming months, before malware. Barring, of course, an amazing new large language model I don't know of, which is going to eat out tomorrow, and then everything is wrong, but that's to the best of my ability where I think we are. And so let's switch side and talk about Blue Team and the place where I am the most excited, where I think it's really going to be awesome. And what does it look like today? And again, I want to predicate that is think about that. And so what I want to do is I want to do something maybe different, which is I don't want to talk to you about, oh, we're going to do this amazing thing or that. What I would like to tell you is about what are the fundamental capability a large model has, and then illustrate it with an example of today, in the sense of let's think about what are the capability, and then as I said, let's think 2 years from now, 3 years from now, how good they will be, and how you can apply it to other capabilities. So the example is just here as a support for the mind and to help you build a mental model. What I really hope you take from the talk is, okay, a model can do this, and that. Where is it going to be useful? How can I help? How can I use it? Maybe not really today, but this is where we're going. And if you have this mental model after the end of the talk, I think I will have succeeded, right? So let's go one by one. So I have 4 capabilities I think which are very important. The first one is reasoning capability. And we're going to talk about that through the lens of scaling content review. Then I would like to talk about multimodal understanding, which is the ability of the model to understand both image and text, and we're going to talk about how we analyze malicious document with that. Then the big one, can't skip on that one, code understanding and securing code base. And last but not least, one of our most recent generative capability for the good guys, and there I'm really, really excited to talk about speeding up incident response, which I think is going to be one of the biggest and first big wins for our community. So let's go in turn. I mentioned it before, but the solution I'm discussing have nothing to do with one specific model or another. As I said, I'm a researcher from DeepMind. I just would like to give you a mental model. Please apply it to whichever model you would like. Hopefully, that helps you in your workflow with your own tooling. So reasoning capability. And here, the idea is let's think about fraud and abuse manual review. And those have to scale to an ever-increasing amount of content on social media and posting and marketing content and email and so forth. And the problem is the amount of content keeps increasing, but human capacity is somewhat plateauing, so it's really, really hard, and it's also very difficult. So how can we use AI to help with that? And so the answer is we'll have to use it everywhere because there is so much we need to review, from phishing and scam, when you have model making a decision and you are unsure, how AI can help us doing better with phishing and scam. How can we detect misinformation? How do we can assess if an information is correct or not? We'll have to do a lot of fact checking. Fact checking is very expensive. How can we help? How AI can help there? How about toxicity, hate, violences, a lot of it on the internet? Can we help? AI can help with that. And last but not least, if you have user report, someone is flagging something wrong on your system, what do you do? And so for all those things, we need manual review, and manual review are pretty much taxed. So here the opportunity is the large model have reasoning capability and generalization capability, and that should help us to do training-less content classification. So what I mean by that is you don't need to have a traditional classifier where you're going to put your data, release something, and then do this labeling and so forth. You're just going to use the model. Okay, so how does it work in practice? Well, very simple. You take user-generated content, and remember, model can do text, images, video, so whatever you want. You pass it to what we call a large model rater, so that's a non-human rater, and then you pass it a policy. And you say, this is what I authorize, this is what I don't authorize. Look at this content and tell me what you think of it. And if the model say, well, seems fine, then you let it go. If the model say, well, I'm not sure, then you escalate it to a human, and so the human only look at the complicated case. And the human say, well, that's not a violation, let it pass. Or you say, yep, that's a bad thing, let's escalate. So this is not a talk about how you use AI, but I want to show you the behind the scenes so you get at least a feeling of how you do such a thing. So the way you do this is you do what is called a prompt. And the prompt is essentially a fancy term for you're going to write a bunch of instructions to your model, and hopefully the model will do what you want, which most of the time it is true. So the way you do it is you say, okay, here's my policy. And you have 1, 2, 3, 4, you have a bunch of articles in your policy, you put it into the prompt, and then you ask the model a question. And you say, hey, look at this, and does this following content will violate my policy? And of course, you ask. You pass the content to moderate, and that's a prompt. So essentially, a prompt is a structured set of data which contain some information, which has an instruction, plus some of the content of the user, and then you try to hope to have an answer. And you say, well, that seems pretty insecure. Yes, there is a lot of insecurity with AI. That is a talk from Wednesday. So for all of you here, I'm shameless plug. There's a talk on Wednesday where I'll talk about how we do AI security. If you haven't reserved your seat, do it, because I'm afraid we're going to be in the same situation than today with a lot of people outside the door. So if you're interested in AI security, take a moment and register for the talk. With that out of the way, let's give you a few tips on how to make those prompts a little bit better. So the first thing we know is you have to add tags. It seems that the model really, really like when you separate things with tags, and that improves accuracy. So think of XML, I guess. You can do it in JSON too, but essentially it's make sure you basically tell the model, this is my section, this is this section, this section. Another thing which is interesting is add a role. So here we say you are an expert content moderator. I would predicate do not go overboard. There is a weird effect called the War-Luigi effect, where if you go overboard and say you are the best content creator in the world or something like that, actually it's worse, because the model learns things in context as it's trained, and so when you have those superlative things, it's actually associated with content which is probably delusional. An expert moderator would look like more scientific. So an accurate curator, an expert moderator, great. The most advanced AI in the world, not good, right? So when you choose a role, be careful about it. Otherwise, you might get surprising answers. And the last thing, and that's a tip people sometimes forget, is start the answer yourself. And remember, the model works by generating token after token, so in a way you are initializing the answer, and then the model is following up. So that's how essentially, when you hear about prompt engineering, that is essentially what it is. Figure out the optimal way to arrange a prompt and put those Lego pieces together such that the model gives you the best accuracy possible. All right, I'm going to also take a moment to tell you a little bit more about the other way people have been improving those workflows, which is retrieval augmented generation, also known, first I need to tell you how you can use that, and then we'll go back to that. So you can use this type of setup with an LLM writer in 3 ways. So the first one we discuss is put it as a front end, and then it absorbs some of the things and escalate what needs to be absorbed. The other idea is use it for rapid escalation. So let's say you are working for a news media company, you're working for social media, and there is a new problem. Let's say the Christchurch shooting, mass shooting, where there's a lot of video online and you need to moderate them very quickly. It's a new problem. Then in that case, you can use the LM writer to immediately escalate. And then when it's unknown, then you reverse essentially, and that's when you need speed and accuracy second to speed. In situation of crisis, that would be something you would do. And then the last one is another approach which is somewhat different, which is you don't change your workflow, but after the fact, you get the model to also revise and rewrite what the human have done, and then you essentially use it as a second control. And that's what it will do is, if both of them agree, fine, then you have confirmation. If both of them do disagree, you pass it to a third human reviewer. And that is when you need to have super high, low false positive Q, and you want to improve accuracies, and you use essentially the LM as a co-pilot for the human writers to deconflict with other additional writers. So it's the best way to improve your level 1 and level 2 support, if you would. So, as I promised, we'll talk about how to improve that a little bit further and talk about the RAG thingy. So what is it? The other way to call it is few-shot. And so we have the same diagram than before. The only difference is we're going to pass the policy and a few examples to the model. And what it's going to be essentially is helping the model to look by analogy and by example, and that will improve accuracy. The way you do it is very, very technical, as you can see, is you create another block, you call it example, and you put your thing into it. And that's what people call RAG, which stands for Retrieval Augmented Generation, which is the thing you hear all about, LangChain and all those frameworks to be able to combine them. So the way you look them up are two options. You do it by hand, you craft your prompt, you put static example if your policy is fairly stable, or if you want to do it a little bit more advanced, you do dynamic retrieval. So basically you compute some sort of embeddings, which is a way to look up other example, and then at processing time you look up some of the related example, put them into the example dynamically, and pass it to the model. And that is essentially what a RAG is. So how good is this? Well, here is some of our experimentation on some data set for testing we did. On election misinformation, we are reaching close to 99% accuracy. And remember, this is without training, right? So the capability is we're able to use the ability of the model to generalize and understand instruction to be able to classify non-trivial piece of content. Hate speech, violent extremism, and harassment are close to the 90s. And as you can see, the RAG do push the accuracy by quite a few percent because it helps to draw analogy and help precise the policy. That said, the RAG can also reduce accuracy, for example, on the top corner, on the top row, that's why I put it here. So it's going to depend on your use case. But essentially, that's how you could use models and their their generalization capability to deal with content that you don't have enough label, or you don't have yet enough label to deal, and use them as a training-less classifier. So another number for you, we did experiment with a third option, which is, hey, what happens if we ask the model to help writers? And here what we did as an experiment is we asked the model to highlight which part of the comments would be problematic. And that really helped manual reviewers, which are very tired because they see a lot of content, by helping them focus on what to review. And that helps in some cases by 9 to 11%. So quite a few ideas on how to use those capabilities, and quite a bit of workflow who can use them. So to recap, reasoning capability are really, really helpful to generalize on use cases where we don't have label, not yet or not enough, or in languages we don't have enough. It works on other languages to a certain extent. The challenges, if you try to implement that, is you have to have policies which are understandable by AI. So if they are ill-defined or you don't have them very precisely laid out, you might have to rewrite your policy to be a little bit more separated and easily more consistent. The second one is that require a massive rework of your workflow because you want to integrate the large language model and the UI and the ability to write a prompt and deploy and so forth. So there's quite a bit of retooling, but once you have done that, analysts can use them, and that's an awesome tool to use. So you get faster response time to emerging threat. We hopefully reduce manual toil, which is very important to make our reviewer well-being better. And you can use it as a secondary reviewer, which will help also reduce further false positive and false negative. All right, switching gears. How we can use multimodal capability to analyze malicious document. So if you've read the press in the last year, you've seen that malicious PDF is on the rise. And here's some statistics for you from our Gmail telemetry. We currently estimate that malicious document blocked by Gmail are made of, 70% of them are made of image and text. And so image, text-only content, which used to be the norm a few years back, have completely shifted to be multimodal. And the reason for that is we used to have a lot of Office documents with macros, and if you have came to the talk A few years back, we had deployed a lot of AI, which is really, really good at detecting those type of malware. And Microsoft have stopped allowing macro by default, so people have switched from a malicious TTP to more like a phishing scam TTP, and that's why we see an explosion of those multimodal. The way it looks like is something like that. Those are not text, those are literally images which are copy-pasted into some of the PDF that we got from VirusTotal and are representative of the campaign we see. And so that's the kind of stuff now we have to classify to be able to keep people inbox clean, and any kind of other provider will face the same thing. And so here, you could say, well, very easy. We just learned about generalization capabilities, so let me just put a model and decide to do training-less classification, and going to pass the image, going to pass the text, and I'm done. And you get 91% accuracy if you try to do that with Gemini on VirusTotal. I don't think that's the right thing to do, because our specialized model gets 99% accuracy and is 100% more efficient. The reason being, there is so much data. It's a classification problem, which doesn't require billions of parameters. So that is probably not the best use of GPU and TPU, and probably not the right opportunity. So here's an anti-pattern. What I would say is like, okay, then what is the opportunity? I think the opportunity is to go one step beyond and offer analyst-level reasoning capabilities. And so what I mean by that is having the ability to offer a meaningful explanation. So here's a concrete example that's a real scam document, which pretend to be PayPal, ask you to pay $2.99 for Bitcoin. So you pass that to the model with a RAG, and what you see is, well, the model clearly understood that is a document which is a phishing attempt for PayPal and should not be trusted. So the model clearly understood the image, clearly understood who was impersonated, and then with the help of a RAG, he was able to say, well, the phone number is wrong. You should not trust it because the phone number is wrong. And that's why it's become super interesting, because the model is able to compare ground truth with what you have in the document and able to make a reasoning that it can pass to the user and can help it understand why the user should not trust the document. And I think that's a next level capability that's very exciting as an idea to combine the RAG and to combine information. And of course, it will tell you, here, of course, you have to have a lot of data to be able to know what is the ground truth, but you can make it work. And then, very interestingly, it's also able to assess correctly that you're going to have to call a specific number, and so they're probably going to steal your personal information, so it also helps the user to understand the consequences. So I think this is one of the most interesting next-gen capabilities that we're going to see. Very briefly, we want to leverage those multimodal capability to basically create analyst level. You will have to do fine-tuning, which is an even more expensive way to train the model with real examples. So that, together to a level of accuracy and level of quality of response, you probably need to actually do far more training than the generalization training less. And that is probably very expensive to scale. So this is really for human interaction or high value analysis, because you cannot do that at the million scale. As I said, large models are expensive to run on GPU and TPU, so you probably only want to reserve that to a very specific use case. On the opposite side, that's a great way to have a front line of defense who deal, or a last line of defense to deal with multimodal attack when everything is fair. It works across any format because it works really on text and images, so you just have to extract them. And as I said, it actually shows sliver of an analyst-level reasoning, which I found quite interesting and that people find, at least in our limited testing, quite compelling. All right, the big one, which is I think the one I'm the most excited for, and which is, can we use the model coding capability to secure our code base? And well, the amount of 0 days is not getting any better. There is still vulnerability in our code base, and the windows of vulnerability, which is how long it takes between the vulnerability is introduced versus its patch, is still quite large. So you really want to find bugs faster. One of the early success we got was to actually improve fuzzers. So fuzzer use a harness, which is how to generate input. And when the fuzzer is stuck, you can probably ask the model to help it out, and you can go deeper into the fuzzing using an LLM. We actually found quite a few success and found quite a few bugs with that. We have a blog post, it's on the link, but that's interesting that it's a natural symbiosis between fuzzing and large language model to kind of find more bugs. So that's one direction. There are, of course, the holy grail of things that people try to attempt. This is GitHub reporting progress on this idea that we would like to have an AI which is able to read a commit and say, well, you know, you're about to introduce a vulnerability. Let's not do this. Here's a patch. Use this code instead, and that way the vulnerability, the windows of vulnerability goes to 0 because we stop introducing bugs into our code base. That would be ideal. That would make the world such a safer place. So that would be awesome if we can get there as a community. And there is quite a bit of talk about that. For example, Jason from Anthropic was super excited when Claude launched because the model was able to reason about a vulnerability which was disclosed after the model was trained. So really like almost on 0 shot, really, really exciting. And of course, we have these amazing challenges called the AICC challenges by DARPA, which essentially in the next year and a half will be able to try to get people to test how to autonomously find and patch vulnerability, and that will be awesome to see the progress there. I deeply encourage you to follow that if you haven't just done yet. Hopefully, a lot of great results will come out of that. Google, Anthropic, OpenAI, and many others are partners with DARPA on that, and we're all super excited to see that happening. Now, I don't think we're there yet. So hype alert. We have to have one of those. There is a bunch of new vulnerability benchmark. They have their own problem, but in reality, what they show is pretty much what is our experience so far, which is models do not generalize for vulnerability detection. I don't think we are there yet. I think the accuracy of that is somewhat overhyped in the current benchmark, maybe because the thing was in training, or maybe because it's too close to a CV and so forth. So far, vulnerability detection is not there yet. And we did confirm also the patching capability last year. We did a very expensive experiment where we took a bunch of vulnerability found inside our own Google code base and asked, write a patch with AI and then submit those patches to software engineers. So we did that for 1,000 bugs. Thanks a lot to our software engineer at Google who spent the time to review those 1,000 bugs. It was quite a bit of an effort. And the reality is we had 15% success rate. And that was with the best model we had last year. I'm not saying the model didn't improve. I'm not saying the model will not improve. Just saying last year, 15% on simple vulnerability found with C++ sanitizer was the max we can do. And we learned quite a bit from that experiment. The first one is, let's be positive, the model was able to patch 15%, which is more than we could ever done. So we are on the right track. Some bugs seem to be easier to patch than others. So there is some class of bug where the model, usually the one which has the simplest number of lines, seems to be better. And there are some impressive capability. Like in one bug, the model was correctly fixing a race condition by adding a mutex. So that's not a trivial thing to do. It's not a whole lot of code, but the concept and the idea that you have a race condition is non-trivial. So the model really shows understanding of code and code principle, which is quite impressive. And it also was able to fix some data leak by doing pointer use. So in a way, it is almost doing the right thing. On the not so great side, only 50% is a very long way to go. And some of the behavior are really, really hard to catch. The first one, for example, was like, well, there's a bug, let me just comment out. You know, problem solved, no more code. And this is where, besides being funny, it shows you how hard it's going to be for AI. Because the problem we have is we need to write an evaluation data set which not only assess if the vulnerability is fixed, but also if the feature of the program are kept intact. And if we want a benchmark for that, we don't need one, we need thousands of those ability to test. And so creating a patching capability is going to be really difficult. And so that is one of the things where we'll have to find a way together to create those data sets because that's hard. Another example where we absolutely know those data sets is the code had a race condition, and we're like, yep, no problem. How about a sequential version of it? Correct, the program functionally works. The problem is not multi-thread anymore, so the performance are terrible. And so feature, if you do a simple unit test, that will work. So the last one, which for me was the funniest one, is like, yeah, I can't fix that, but what I can do is I can remove the unit test so you know it passed. Technically true, not what you want. And those are funny, but they also highlight the difficulty of testing code patching and why this is going to be a community difficult effort to really create the data set and the testing and the confidence we have. Also, I think we have to be careful of not overwhelming people with too early result. 3 years ago, people already tried that with different models, which were transformer, which were encoder only, right? Same architecture, different ideas. And they sent a bunch of patch to the Linux kernel foundation. And those patches were meaningless. They wasted time from engineers, from the Linux kernel foundation, which have other things to do. And they get bad. And I think one of the risks we have as a community is AI tools are amazing, but we need a very, very high level of accuracy to make them really practical and useful. And it's very easy to go from 0 to 15% apparently. 15 to 80 might be good, but then to reach the 90, 95% we need, bearing an amazing new LM model that I don't know of just yet, but maybe that happen, we have a long way to go to have them as autonomous. I think for now, we'll be more onto the AI assisting human. Very briefly, so code capability, to find patch vulnerability, that's the big one, the one I'm super excited about, and I hope we get there as a community. I said validation is complex, data question is complex, and even training is going to be complicated because we simply don't have enough data. There's only so few vulnerability we know. The model needs way more than that, so how we get there is going to be interesting. But the upside are massive, and so I really hope we get there. So very briefly, I want to talk about generative capability, but from the good guys, and what I would like to report is a little bit of discussion on incident response. And incident response is really the place where I think we see the most rapid progress, because in incident response, time is of the essence. The faster you are, the better we are kicking the adversary faster. This is where we need to, AI will really, really shine in my opinion. And so what we want is get the model to help analysts to do the heavy lifting, so we go faster, 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 to the point where our reaction time goes, I don't know, 10x smaller. That would be my idea. And you're like, okay, that seems a little bit ambitious. Wait. So we run this experiment, thanks to our amazing incident response team, where we say, write me an incident summary. And what we're going to do is we're going to write it twice. So kudos to them for doing it. We're going to write it from scratch, and we're going to write it starting with an LLM-generated version of it. So you pass your incident work log to the model, and then you ask, generate this. And what you can see is, if the time is equivalent, no time is saved. So far, we are quite confident that, at least for our summaries, the model are able to write incident summary 51% faster. And for us, that is super encouraging. So it's only summary for now. There is a lot of other applications where we might need something else, but we really believe that that helps a lot. And you're like, okay, how good are the summary? Well, we got that covered too. Our early experiment, we asked other people who were looking at, such as Incident Commander, how good is the LM summary versus the human summary, and they are basically comparable. So that's very interesting because it means that if we get the model to do the first version and then the analyst is using it as a draft and work on it, we'll get pretty far into speeding up incident response. And that's only one aspect of incident response. So really excited to see those generative capability being used to assist the cybersecurity analyst workforce. Same technique, we talk about prompt structuring, same idea. You have to be very precise to be able to do it. And we have a ton of field. They're all in the blog post we wrote about, I think 5 days ago about it. So you can look at the exact prompt we use. You have to be pretty principled, but that's worked pretty well. So for me, that's one of the most exciting things for the immediate term, which is using the capability of the model to speed up things where we need a lot of text generation, image generation, and so forth. I think that's going to be a place where we'll see the most rapid progress in the next few months. Be careful of the data input, and you need a human in the loop, right? I'm not saying you should do it autonomously. I'm saying it's a really good code assistant for security. And you get faster summarization and more consistent summary, which is awesome. So capability recap, reasoning capability, allow you to deal with unseen data. Multimodal allow you to deal with attacks which use a diverse set of things. code understanding hopefully will help secure our code base, and generative capability will help us to speed up our workflow. So I'm going to keep that. I would say if you want to apply, I think you should spend a moment to think about where you can apply it for once, and then in the next 6 months, try to implement at least one workflow. As I mentioned, if you're interested in AI, we'll talk Wednesday about how we secure AI workflow at Google. If that's of interest to you, please come to the talk. And I would like to thank all of you for coming today, and I hope that was helpful and help you make better sense of where we are today for AI cybersecurity. And hopefully you find that useful for your own workflow, and I can't wait to see what we're going to do together as a community. Thank you.